Next. Okay. Today, I just want to talk about some technical things, okay? Something that you can improve, yeah? I'm going to talk about roughing, okay? Because if you talk about a cycle time, okay? Let's say if you have a part, okay, of course first you need to do roughing, right? Then maybe later semi or finally the finishing. So if you try to focus to reduce the cycle time on the finishing process, you cannot, right? Because the finishing process, the pitching, and the feed rate on the machine is controlled by the surface quality. You cannot. Maybe a little bit, but most of the time you cannot. The only area that you can focus on how to reduce the cycle time is actually roughing. That means you should try to remove as many material as possible, okay, at the very, very short times. Okay, so today I will focus on rough milling. And of course, rough milling, if you have parts like this, big part, the best cutter that you're going to use for rough milling, I believe will be some cutter like this, round insert cutter, okay, for this kind of part. Okay, and see, of course, Cimatron, we have a lot. I cannot explain all the function in one day if you give me the time. I cannot. Okay, if you want to know how to use this kind of cutter to machine a very big part, complex part, very efficiently, okay, you can contact Mr. Jesada. Jesada? Okay? So, he will be free to explain to you. Okay? Okay, I'm not going to talk about this. No, today. Okay? So what I'm going to talk about today, I am going to talk about what if you cannot, what if in some cases you want to machine some part, you cannot use the insert cutter. Okay? What if? Okay? What if you have to use a solid mill to machine the part? In some case like this, maybe. Some inserts, okay? Look at that. How to do that? Where's pointer? Meter? Where's the laser light? Sorry. Yeah? Yeah. Okay, sorry. Yeah, there you are. So if you have parts like this and part like this, or small insert, small punch, if you do stamping, small punch, of course you're not going to use the big face mill to rough the thing. One thing, because you cut this part in a small machine, right? Small machine don't have the power for you put in the face mill. You understand? Due to that, many reasons you have to use this one, solid mill, to do some roughing. Okay. And what if today we tell you, Mygrowtech, we have a proven solution. Proven. Okay? This is not just talking. Okay? It's a proven solutions that can do what? If you cut this kind of part, we can ensure we can extend your tool life up to 800%. We have a proven solutions. And reduce the cycle times of your current part, any part, okay, up to 80%. Okay? So, If I have this kind of solutions, do you want it? Do you want it? You want to know about it? Only one? How many people? 2. Okay. Because at least we have 2, so I can continue. If nobody raises a hand, maybe I will stop. Okay. Okay. Extend the 2 life to 800%. It is possible? Is possible? Now I'm trying to answer your question in theory. Is it possible? First, we look at this. Conventional milling. That means the old roughing strategy. The strategy that you are using now. Okay? And in the old roughing strategy, if I'm going to use this cutter to cut a pocket, I'm talking about closed pocket also. A pocket. Okay? Normally, I'm going to ask you all, normally, how the down step, you put how many % of the tool? For example, this cutter is 10 mm. So the down step, how many mm you put normally? Anybody? 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 Based on your experience, I believe you have some very good engineer here, right? No? No engineer know the answer? I think we have boss also here. Some boss is over here. Engineer, please don't let your boss down. Okay? Okay, if nobody answer this, I will answer it. Okay. Actually, the answer is here. Answer is here. Normally, if the cutter is 10 mm, you're going to use maybe 1 mm or 2 mm. That's all for the down step to cut each layer. Okay, and of course, the side step, you use 40% of the cutter. That is quite normal. Okay, this means in the old way of roughing, you are using only this 1 mm or 2 mm of the cutting edge, of the whole cutting edge to cut the part. Okay? To cut the part. And okay. And let's say, okay, for this cutter to finish the pocket, you need to cut 5 layers. Okay? And let's say, if this cutter, after cutting 5 layers, you need to change the cutter. Okay? Need to change the cutter. Let's assume this. Okay. Next, I'm going to talk about a new way. Okay? What if we have a new way to cut the part? Instead of 5 layers, we cut 1 layer. Just 1. Okay? If this hole, the depth is 15, we just go 15 mm. And then we will utilize the whole cutting edge to cut this part. Okay? What if we have application like that? Okay. So now my question is, okay, since this cutter able to cut, for the old milling, it's able to cut 5 layers on one part, and the cutter you need to change. Now I'm going to ask you, if I have a strategy that can use this kind of a method, okay, my question is, my cutter can cut how many pieces of the same part? Sorry? 5? Any other answers? No? Of course, no? Okay, I have to do this. I don't want to do it, but I have to do it. Do you see here? Inside this thumb drive, inside have some very nice pictures. Okay? The first people who give me the correct answer, I'll give him this thumb drive. It's not a thumb drive. Okay? Here's the picture inside. Very nice. Okay? So he said 5. Any other figure? 8? Any other figure? Yes? Huh? 1? Okay. Because of times I cannot continue. Okay, I will review the answer. Okay? In theoretical. Okay? What? You should cut 5 parts with the same tool. Okay? So, can you pass this? Yeah. So if you see some funny picture regarding me, please delete it. Okay? Thank you. Yeah. This shows that here I can prove to you without talking about a lot of formulas, a lot of mathematics. This is common sense, right? If I can use the full cutting edge to cut the same part, I can cut 5 parts, right? And just imagine if one cutter, it costs you maybe, normally how much one cutter costs you for diameter 10 here in Thailand? 4,000 baht, okay? Then you just calculate how much you can save from there, right? Okay. So with this, I can prove to you, is it possible to extend the life? Yes, it is possible. What you need is a spatial roughing strategy, a spatial 2-part. This is what you need. Okay. So next. Okay, is it possible? Possible. Next, I'm going to talk about another point. Just now I also say, I can very confidently reduce your existing cycle time by up to 80%. Okay? 80%. So is it possible? Next. Now it's a little bit complex, some formula, something like that. But I believe if you are an engineer, you should understand what is this formula, how to calculate RPM, how to calculate the feed rate, right? Yeah, should not be a problem. So my next question, again, I should have another thumb drive here somewhere. Yeah, again, if you see some pictures that you don't like, please delete it. Okay, my question is, okay, what is cutting load? What is cutting load? What controls the cutting load? What related to cutting load? Okay, if I say the cutting load is very heavy, okay, what do I mean? This is my question. A little bit more complex, yeah. Any answer? What is cutting load? Cutting load equal to what? Cutting load. What is cutting load? Chip thickness. Any others? Answers? Okay, I'm going to count 3. If no, then I'll give the thumb drive to Mr. here. 3, 2, 1. Why is it? Sorry? F size fit per tooth? Okay, he say fit the tooth. Okay.